Hey there, science fans. Today let's talk about electricity, but not the kind that makes your lights turn on. We're diving into the world of capacitor banks, those unsung heroes of the electrical grid that keep our power systems running smoothly. Imagine a water tower. It stores water and releases it when needed, right? Well, a capacitor bank is like a power tower for electricity. It stores electrical energy and releases it in a flash when the power grid needs a boost. This is particularly important for industries that use a lot of electricity. Think factories with heavy machinery or data centers powering the internet. Capacitor banks are made up of multiple capacitors connected together. Now, a capacitor is like a tiny battery that can charge and discharge electricity very quickly. When these capacitors team up to form a bank, they become a powerful force in managing and improving the quality of electricity. Now, let's get a little more technical about how these capacitor banks actually work. You see, electricity in our power grid flows in waves, and these waves need to be in sync for our appliances and machines to work properly. This synchronization is called power factor. When the power factor is off, it's like trying to run a marathon while dragging your feet. It's inefficient and wastes energy. Capacitor banks act like little helpers that correct this power factor, making sure the electrical waves are in sync. They do this by storing electrical energy when there's too much of it and releasing it when there's not enough. Think of it like this. Imagine you're on a seesaw and someone much heavier is on the other side. The seesaw is unbalanced, right? A capacitor bank is like adding weight to your side, balancing the seesaw and making everything run smoother. Just like there are different types of batteries for different devices, there are different types of capacitor banks designed for specific purposes. Some capacitor banks are fixed, meaning they always provide the same level of support to the electrical system. Others are automatic. They can sense fluctuations in power demand and adjust their output accordingly. Then there are detuned capacitor banks, which are specially designed to handle the unique challenges of industrial settings with lots of heavy machinery. These banks help to filter out electrical noise and harmonics that can interfere with sensitive equipment. So why are capacitor banks so important? Well, they bring a whole bunch of benefits to the table. First and foremost, they improve energy efficiency. By correcting the power factor, they reduce wasted electricity, which translates into lower electricity bills. And who doesn't love saving money? On top of that, capacitor banks help to improve the reliability of electrical systems. They provide that extra boost of power when it's needed most, preventing voltage drops and brownouts that can damage equipment or disrupt operations. In a world that's becoming increasingly reliant on electricity, capacitor banks are essential for ensuring a stable and reliable power supply. So there you have it, capacitor banks, the silent guardians of the electrical grid, working behind the scenes to keep our lights on, our machines running, and our digital world powered up. They may not be the most glamorous part of the electrical system, but they play a vital role in ensuring a brighter, more efficient, and more reliable